suppose the dipole is placed in a non-uniform electrostatic field. Electrostatic field. Okay, what we get? This is our non-uniform field. Suppose the field is increasing in this direction. Vector E, increasing field. Its value is increasing from left to right. Okay, here minimum value and here maximum value. It is non-uniform. And the dipole is placed parallel to the field direction. Parallel means here minus q and here plus q. Dipole moment is parallel to acting from minus q to plus q. Dipole moment direction is from minus q to plus q. So vector P is parallel to the increasing field. Okay. So you can calculate the force acting on plus q, force acting on minus q. Since the field is increasing, oru force E plus q into E becomes greater than minus q into E. Okay. Since the field is increasing, plus q into E, increasing field, becomes greater than minus q into E. Okay, the magnitude of plus q into E. Why? Minus q is here, plus q is here. Plus q coming in the increasing side of field, minus q coming in the decreasing side of field. Okay, so this value is less than this value. So we get, thus we get a resultant force. Previous case, uniform field, there will be no translatory force. Here a translatory force is acting in this direction. Okay. Second case, you are placing the field dipole anti-parallel to the field direction. Dipole is anti-parallel to the field direction. This is increasing field. Field is increasing in this direction. Dipole is lying opposite to, this is the direction of dipole moment. Okay. So in this case, dipole moment is acting in this direction. Clear? So minus q into E is coming here. Minus q is coming in the increasing direction and plus q is coming in the decreasing direction. So plus q into E becomes greater than minus q into E. Because it is minus q into increasing field becomes minus q minus force greater. Minus force greater. And this is plus force. So a resultant force is acting in the opposite direction of field. Opposite direction of field. Okay, I'll show in the diagram. Resultant force is acting in this direction. Resultant force is acting in the direction. Previous case, resultant force is acting in this direction. Okay, instead this parallel and anti-parallel position, if it is making an angle, this is our field, increasing field or decreasing field, and the dipole is placed in this form. Dipole is placed by making an angle. Okay, this angle is there. So in this case, we get, if the dipole is inclined, we get resultant force and torque. Okay, this case when it is parallel, theta is 0, so no torque. Anti-parallel, theta is 0, no torque. Okay, because torque is P E sin theta. When it is inclined, we get a torque and force. Force is there, also torque is there. In all the three cases, in non-uniform field, we get force. And the last case, we get torque.